Hi students, in this video I'll be going through the 2023 O-Level A Math Paper 2 question 2. Alright, so this is a question on proof of plane geometry. Okay, so let's read the question. So a diagram shows a circle, okay, with center C, okay, with FD as the diameter. So do take note that FD is the diameter of the circle. Alright, the tangent at point B on the circle. So there's a tangent at point B. So the tangent is AB okay? ABE is the tangent, okay? Meets DF extended at point A. Okay, so DF is the diameter, remember, and when you extend it further, that means the DFA is a straight line. It will meet the tangent at point A, right? Okay, so point E lies on AB extended. So ABE is also a straight line, so it's a part of the tangent now. Okay, ABE is the tangent. Alright, and X is the point of intersection of BD with EC, right? Okay, so for the first part, they want you to prove that triangle ABD. So I've drawn in green already, triangle ABD. Okay, similar to triangle AFB, AFB. Okay, so for similar triangles, you need to recall what are the tests for similarity. Okay, so basically, test for similarity, there will be 3, right? Okay, so the first one is SSS. Okay, then the second one is SAS, and the third one would be AA. Right, so you need to consider which of the 3 is the most likely that you should be using here, and then you will focus on trying to prove the things that are required to show okay. Alright, so if you look at this question, no lengths are given. Okay, no lengths are given inside the question. The lengths of the sides are not given in the question. Okay, so if you see a question whereby there are no lengths given, right, then it's unlikely to be SSS or SAS already. Because for SSS, you need to prove that the ratio of 3 corresponding sides of the 2 triangles are equal. So since no lengths are given, you will not be able to find any ratio. If you are not able to find any ratio, then you will not be able to use SSS. Okay, same thing for SAS. SAS, you need one pair. Okay, there's 2 S over here. Okay, you need one pair of ratio of corresponding sides to be equal. Okay, before you can use SAS. But then again, like what I mentioned, no lengths are given in the question. If no lengths are given in the question, then you will not be able to find any ratio. Okay, so these 2 will be out of the equation already, okay, out of the question. Okay, so then we will try to focus our attention on doing AA. Okay, so for AA, you need to prove 2 pairs of angles are equal for the 2 triangles, okay, so 2 equal pairs of angles, all right. Okay, so let's go back to the question. So triangle ABD, the one in green, is similar to triangle AFB. So I've drawn one side of AFB in red now, okay? So to differentiate the 2 triangles. Okay, so one thing to know about similar triangles is you can see both of the triangles have the vertex A. Okay, both triangles have the vertex A. It means that there is likely to be a common angle. And indeed, for this case, there is a common angle. Okay, so you can see over here, BAD. So BAD is over here, and FAB for the smaller triangle, right? Okay, they are both actually the same angle. Okay, so this will give us our first pair of equal angles already. Okay, so we can write that down. So angle BAD is equals to angle FAB. Okay, and this one is a common angle, right? Okay, so we have our first A already, right? So now we need to prove one more pair of equal angles. Okay, so let's think about what we have in the question. Okay, so you see the question here, we have a tangent. Okay, and this FB, right, the red color line, which part of the small triangle. Okay, if you let's see if you agree with me. Okay, this any angle that is formed between the chord and the tangent, right? Okay, this one. Okay, then we should be thinking about angles in alternate segment. Okay, so basically what is the angle in alternate segment? If you recall, let's say we have a circle over here. Okay, then you have a tangent over here. Okay, at this particular point. Okay, then after that you have a chord. Okay, and one end of the chord is the point at, which is tangent, at which the line is tangent to the circle. Okay, then you will be able to get an angle between the chord and the tangent, right? Okay, then when you extend the chord to form an angle at the other segment of the triangle, this angle formed here, this angle, let's call it angle A, and this angle will be equals to the angle between the chord and the tangent. Okay, so this is called angles in alternate segment. Why angles in alternate segment? Because they are in different segments of the triangle. Okay, so you can see over here you have the chord. Okay, let me change the color of my pen. Okay, so you have the chord over here. Okay, so this angle is on this side of the chord. On this side of the chord, right? And then this angle over here is on this side of the chord. So this chord basically divides the circle into two segments. Okay, one segment is over here. Okay, so this is we can call it segment 1, and then the other segment, okay, let me change the color of my pen. Okay, the other segment will be over here, this side. Okay, the major segment. Okay, so because they are on different segments, so we call these angles in alternate segments. So angles in alternate segments, right? Okay, so whenever you have a chord and a tangent, okay, you should always be looking out for this particular property, okay? Angles in alternate segment. So indeed, in this question we have, okay, so we have a chord BF and we have a tangent ABE. So the chord and the tangent forms an angle. Okay, and you can see that the chord, which is red in color, right? Okay, if you extend it, okay, using the lines BD and FD, it's going to form an angle at the circumference over here. Okay, so these two angles are going to be equal. And indeed, if you think about this question, this angle over here, okay, ABF is inside the small triangle, and then ADB is inside the big triangle. Then we have our second pair of equal angles already. Okay, so angle BDA equals to angle FBA, right? So this one is angles in alternate segments. Okay, so we have our AA already. Okay. Okay, so if two angles in the triangle if there are two corresponding equals angle in the two triangles, then the third angle in the two triangles will automatically be equal. Okay, because sum of angles in a triangle is always equals to 180, right? So we can conclude, therefore, triangle ABD is similar to triangle AFB, and we are using the AA test. Right? Okay, so plane geometry questions as you can see, is a 4-mark question. Okay, but the working is only 3 steps only. Okay, so plane geometry questions don't have to be afraid. Okay, just apply you just need to do more practice. Okay, so that you know the properties of the circle well. And usually the plane geometry questions are rather easy to do one. Okay, the working is short. Okay, and it's easy to prove the things that they want you to prove. All right, not too difficult. Okay, let's take a look at part B of the question. Okay, so for part B of the question, they say that a circle can be drawn through BCX with the diameter, with BC as diameter. So I've drawn the circle already. So it's the red color circle. It passes through on the circumference of the circle. Okay, that you can find point B, point X, and point C. And then BC, which I've drawn in the blue, it's not given in the diagram, is the diameter of the small, the red circle. Okay, so they ask you what type of quadrilateral is EBFC. So EBFC are already outlined in green. Okay, so they're asking you what type of quadrilateral. So quadrilateral is a four-sided figure, right? Okay, a four-sided figure. So four-sided figure, there's many types. It's square, can be a rectangle, can be a kite, okay, can be a parallelogram, okay, can be a trapezium, and so on. So they're asking you what type is it, okay, and you've got to give your reasons to support it. All right. Okay, so over here, the moment you see diameter, okay, diameter, okay, you should be thinking about circle properties, angle properties that are related to diameter. Okay, so the first one that comes to mind, okay, will be right angle in a semicircle, right? Okay, because whenever you have a diameter, so diameter is actually also a chord, okay, but it's the longest chord in the circle. Okay, so if you extend out and form an angle at the circumference, right, from the diameter, the angle at the circumference is going to be 90 degrees, okay, the angle at the circumference. So you can see that BC is the diameter. So if I extend out this way and this way, it's going to form an angle over here. And this angle over here is going to be 90 degrees because it's a right angle in a semicircle. Okay, because the blue line is the diameter, and then this half of the circle, okay, the bottom half, if you go this direction, okay, then you get a semicircle, okay, and this angle over here, okay, is formed by the diameter at the circumference, okay, of the circle, so it's going to be 90 degrees. Okay, so over here, okay, we will have this angle as 90 degrees. Okay, so we already have one 90 degree. Okay, so is there any other diameter inside this question? Okay, is there any other diameter that you can find inside this question? Okay, so if we are able to find another diameter, then maybe we can have another 90 degrees. And if the two sides okay, they are both 90 degrees to the same line, then they will be parallel to one another. Okay, then after that, if the four-sided figure has a pair of parallel sides, then we can conclude that it's going to be a trapezium, right? Okay, because a trapezium has one pair of parallel sides. Okay, the other two sides are not parallel. Okay, so if you have one pair of parallel sides, then it's going to be a trapezium. Okay, so maybe I can think about this. Because if you look at this quadrilateral, right, it's definitely not going to be a square. Okay, the way that it is formed, okay, the shape, one look, you know, it's not a square, it's not a rectangle, it's not going to be a parallelogram. Okay, so it's not going to, it also doesn't really look like a kite. Okay, it looks a bit like a kite, but the length EB looks a bit shorter than the length EC. Okay, so what you can zoom in will be a trapezium. Okay, one pair of parallel sides. So to prove that one pair of parallel sides, you have this line, and then we already show that there's a 90 degree, right? If we can show that there's another 90 degrees somewhere, then these two angles are interior angles that add up to 180. Okay, so the two opposite sides has got to be parallel. Okay, so going back to my question, do you see another diameter or not? Yes, the other diameter would be DF. Okay, remember DF is the diameter of the circle, correct? Okay, FD. Okay, can you see over here? FD is the diameter of the circle. Okay, so if FD is the diameter of the circle, then the angle that is formed by FD, okay, by FD, you extend out to form an angle at the circumference, right? Okay, the angle is going to be equals to 90 as well. Okay, so you can see over here. Okay, let me change the color of my pen. Let me change it to a bit blue, okay, dark blue. Okay, so FD, if I go this way, okay, then I'll reach point B, right? If I go this way, then I'll reach point B also. So this angle over here, okay, is going to be equals to 90 degrees. Can you see or not? These two 90 degrees are opposite one another, and they are both formed along the line BD. Okay, along the line BD. Okay, so this means that BF is parallel to EC, and this shape is going to be a trapezium. All right. Okay, so let's write down the working. So angle BXC. Okay, so I'm going for this one first. Angle BXC equals to 90 degrees. Okay, and why is it 90 degrees? It's a right angle in the semicircle BXC. Okay, so it's a right angle in semicircle BXC. Okay, then the next one, angle DBF equals to 90. So now I'm going for this one, angle DBF. Right, it's 90, so it's a right angle in semicircle DBF. Okay, DBF, right? So angle BXC plus angle DBF will be equals to 90 plus 90, right? Okay, so now I'm just trying to show that this pair of interior angles add up to 180. Okay. Okay, so we can conclude that hence BF is parallel to XC. Okay, and EBFC is a trapezium. Okay, so maybe you can add in the word since now. Okay, since angle BXC plus angle BDF equals to 180, okay, then BF will be parallel to XC. Okay, and then EBFC will be a trapezium. Okay, so you can see that so this is a 5-mark question, but once again you can see that the working steps are very short. Okay, so all you need to know is you need to know the properties very well, angle properties very well, and then you should be able to solve the question rather easily. Okay, so be confident, do more practice, and then yeah, just practice more. Okay, don't look at the answer key so much. Just go ahead, try the question. Even if you can't do, okay, you just come back and try again on another occasion, and then you will gain confidence. All right. Okay, so I'll see you in the next video.